This is Unit 3, Day 5. We're going to start with the zero product law property. Okay, so it says, if the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. Makes sense because any number times 0 results in 0. Therefore, if it's equal to 0, they're just saying one of them has to be 0. Okay, example 33. Solve each of the following equations for all values of x. So these are already factored for you. So then in algebra we learned. So you kind of split down the middle, and then you would set each of these equal to 0 and solve for x. So I'm not going to show my work, but on the left side here, you would minus 7 from both sides, and you're going to get x equals negative 7. On the right side, you'd add 3 to both sides, and you're going to get x equals positive 3. Okay, split down the middle. This one's pretty easy. That's a positive 4. But if you're not too sure on what that one is, you're going to solve for x. So you would move that over to the other side, and you're going to get 2x equals positive 5. Divide both sides by 2, and you'd get x equals 5 halves. Okay. Part C, you have 3 parts. So you would set 4 equals to 0, which is not true, so that just kind of eliminates it. And then all of these, you're going to do the same thing. So this one's going to be x equals negative 2/3. And then this one's going to be x equals positive 3/4. Part D says, in example 33C, why does the factor of 4 have no effect on the solution of the equation? Well, guys, 4 is a constant. Okay, so because 4 is a constant, 4 can't equal 0. So 4 can't equal 0 because 4 is a constant. Okay, and think about that. 4 times 0 is 0. Okay, all right. The zero product law can be used to solve any quadratic equation that is factorable, which is not prime. To utilize this technique, the problem solver must first set the equation equal to 0 and then factor the non-zero side. Okay, so I would add 2x to both sides here, and then I would minus 10 from both sides because I'm trying to set that equal to 0. So I'm going to get x squared plus 5x minus 24 equals 0. Now this is going to become factoring, so you have to say what multiplies to a negative 24 but adds to a 5. We're going to get x plus 8 times x minus 3. Split down the middle, and it would result in an x equals a negative 8 and x equals a positive 3. So you can see how the signs just get flipped. Okay. Next one here, you want to keep the x squared term positive. So you have to bring this x squared over to this side. So I'm going to minus an x squared, I'm going to minus the 3x, and I'm going to add the 2. So I'm going to be left with 2x squared plus 9x minus 5 equals 0. Now, always try and run a GCF check first, but a 2 won't come out of all those. So now this becomes either a slip and slide, AC method, or guess and check. Okay, so I'm going to do a little slip and slide. So I'm going to slip the 2 out. It becomes x squared plus 9x minus 10. I get that from multiplying a times c. Now I'm going to factor this old school here. So you're going to say what multiplies to give you a negative 10, but then would add to a 9. It'd be x plus 10, x minus 1. Slide the 2 in front of both binomials again. And then reduce. So divide both those by 2. You don't write that down anywhere. I'm going to get x plus 5. And that doesn't reduce, so I'm going to get 2x minus 1. Now my last step is I'd split. This is x equals negative 5. This is x equals positive 1/2. Example 35. Consider the system of equations shown below consisting of a parabola and a line. Okay. Find the intersection points of these curves algebraically. Okay, anytime they want intersection points, as long as they have y's isolated, you just set these two equal to each other. Okay, if y wasn't isolated, you have to isolate y first and then set them equal. So I'm going to get 3x squared minus 8x plus 5 equals 4x plus 5. Okay, so I want to move this right side over to the left. So I'm going to minus a 4x and I'm going to minus a 5. So I get 3x squared minus 12x equals 0. Now for me to factor this, guys, it's not a trinomial. It's just a simple GCF. Okay, so I'm going to divide a 3x out of both terms, and I'm going to be left with x minus 4. Okay, I split down the middle. If I have 3x equals 0, I divide both sides by 3, I get my x equals 0. Over here, x is positive 4. Okay, so now remember, guys, those are my x coordinates for the intersection points. So that means I have the point 0 something and I have the point 4 something. Oops. So to get the y values, you could just plug, come back up top, and do 4 times 0, which is 0, plus 5, you get 5. So 0, 5 is my intersection point. And then when x is 4, come back up top, 4 times 4 is 16, plus 5 would be 21. Those are where the parabola and that linear equation are going to intersect. All right, now I did use my table of values to kind of help me graph this. But basically, it's a little funky, but 1, 2, 3, 1, 2, 3, 4, 5. There's 5. Okay, so I know 0, 5 is on there. And then again, just put your 3x squared minus 8x plus 5 in your calculator and just graph it. So I think we have x-intercepts here, then there's one here, and then it's at negative a third for the turning point. So if this is 1, it's right around here. Okay, so you get something like this. Here's my parabola. And then if I were to graph that, I have a y-intercept at 5. You're going to go up 4 over 1, or to reverse it, 1, 2, 3, down 4 over 1. I get my linear like this. Now when I first draw this in, you're going to say it only intersects in one spot. But don't forget, guys, this parabola will continue. And then the intersection point is over 4 up 21, which we already found down here. Okay. All right, it says verify your answer in part A by using the intersect. Guys, that would be menu. 8 is geometry, 1 is points and lines, and 3 is intersection points. Okay, and so then that verifies that your intersection points are 0, 5, and 421. Example 36. The zero product law is extremely important in finding zeros, the x or the x-intercepts of a parabola. Guys, this is also known as the roots or the solutions. The parabola shown to the right has the equation, and it gives it to you. Write the coordinates of the two x-intercepts. Okay, so now remember, x-intercepts are your roots where it crosses over. So remember, the x-intercepts are where y is equal to 0. So I'm at negative 1, 0, and I'm at positive 3, 0. It says find the x-intercepts of this parabola algebraically. Remember, the x-intercepts are when the y is 0. So all you do is come back up to this basic equation, and right here where it says y, you substitute it as 0. So you're going to get 0 equals x squared minus 2x minus 3. Now we can factor that. So you're kind of saying what multiplies to negative 3 but would add to a negative 2. It's x minus 3 and x plus 1. Okay, split the middle. You're going to get x equals positive 3 and x equals negative 1. Remember, those are the x coordinates only. So you have an x coordinate of 3, you have an x coordinate of negative 1, and then you plug back in your y's are 0. So we just proved it algebraically. All right, moving on here, example 37. Algebraically find the set of x-intercepts for each of the parabolas. So as soon as you see x-intercepts, it means set your y equal to 0. All right, so ready? 0 equals 4x squared minus 1. And then in your head, you have to just decide, is that a GCF, a greatest common factor? Or is that a DPS, a difference of a perfect square? Or is it some form of a trinomial that I could factor? Well, it's a difference of a perfect square. Okay, how do I know? It's a binomial, it's subtraction, and everything are perfect squares here. So, two sets of parentheses. One's positive, one's negative, and then I square root everything. So I'm going to get 2x plus 1, 2x minus 1. Split down the middle. This would give me the value negative 1/2. This is going to give me the value of positive 1/2. Now you might say, well, how am I getting positive 1/2? Don't forget, it's 2x minus 1 equals 0. So you would add the 1 to the other side, and then divide both sides by 2. And that's where I'm getting that positive 1/2. Okay? Part B. 0 equals 3x squared plus 13x minus 10. Okay, make sure that the 3 can't be factored out through a GCF, but now you're either going to do a slip and slide or an AC method or guess and check. Okay. So I'm going to do, I think I just basically did a guess and check. You could also use your polyroots key, but you're going to realize that that will factor to an x plus 5 and a 3x minus 2. Split the middle. I get x equals negative 5, and I get x equals positive 2/3. Okay. I should list these as x-intercepts, though. So up here, that would be negative 1/2, 0. And this would be positive 1/2, 0, because that's the x-intercept. So for this one, it's negative 5, 0, and positive 2/3, 0. Last one here, part C. 0 equals 5x squared minus 10x. That's a GCF, okay? So I can factor out a 5x from both of them, and I'm left with x minus 2. Split, 5x equals 0, divide both sides by 5, I get x is 0. So that will give me the coordinate if x is 0, y is 0. So the origin is an x-intercept. Over here, I get x equals positive 2, so 2, 0 is also my x-intercept.